The airline industry is possibly in one of the most fragile positions it has ever been in, largely because of the recent pandemic that has massively impacted the number of flights taking place. But now, as we start to see a way out, people are less likely to take so many flights because they're more accepting of things like online conferences for business meetings. However, I imagine people will start to want to travel more in the future. But with the high per kilometre emissions of current aviation, it is likely people will be encouraged away from it and towards other methods of transport. So to enable the aviation sector to recover, I think it is vital we reduce the emissions from it. But how will that happen? Electric planes are spoken about a lot, but the low energy density of batteries when compared to aviation fuel means it may never be possible for large long-haul planes, or at least not for a very long time. Though I do think electric planes will be feasible for shorter and smaller flights. However, when dealing with large, long-haul flights, I think one of the most promising solutions comes from hybrid electric planes. Before looking at why these may be part of the answer for low-emission flights, it's good to look at the different types of emissions. The main ones I want to look at are small particulate emissions, nitrous oxides, and carbon dioxide. These emissions need to be reduced due to the issues they cause related to climate change and poor air quality. Electric planes can tackle all of these, as renewable sources could be used to create clean energy with little to no CO2 emissions, and there is no onboard combustion to emit particulate and nitrous oxide emissions. Also, planes using clean synthetic fuels could largely stop carbon emissions by taking it out of the atmosphere when it is made and releasing it again when it's burnt. However, this still creates nitrous oxide and particulate emissions as it burns and flows out the back of the jet. This is where I see hybrid planes coming in. They can benefit from the high energy densities of liquid fuels, but also use after treatments to remove particles, nitrous oxides, and other harmful emissions. Let's see how this is possible. A number of hybrid planes have been proposed over the years. Here is the E-Fan-X, a joint venture by Airbus, Rolls-Royce, and Siemens. This plane uses an onboard generator to take liquid fuel, turn it into electricity, and power a large electric ducted fan. However, the other three jets are conventional ones that use the liquid fuel directly. This in itself doesn't really solve any of those emission issues from before, but is a key stepping stone towards other hybrid planes. As with a standard plane, carbon emissions could be mostly removed from the synthetic fuels, but the issues of particulate and nitrous oxide emissions are still around. This is because when they are formed during the fuel's combustion, they're shot straight out of the back into the air. This is where the new hybrid electric plane proposed by MIT is different. The proposed plane would only use electric ducted fans, much like the one from the E-Fan-X. This would mean all the liquid fuel on board is used by a large generator in the hold, which powers the fans. To deal with the carbon emissions, sustainable synthetic fuels would be needed. But by having all of the combustion happen in the hold, the exhaust gases, which contain the nitrous oxides and particulate emissions, can be put through an after-treatment system, much like catalytic converters found in vehicles. The MIT scientists predict that this can cut the nitrous oxide emissions by 95%. These catalytic converters work by introducing rare metals like platinum, palladium, and rhodium into the exhaust gases. These act as catalysts, which mean they speed up the rate of a chemical reaction. In this case, the reaction is turning harmful gases, like nitrous oxide, into non-harmful gases, like nitrogen and oxygen. For a bit more detail on this, I recommend watching this video by Donut Media. I'll leave a link to it in the description below the like button. This concept by MIT very much remains a concept for the time being, but a similar project by an MIT alumni has apparently made some good progress. This is Zunham Aero, who have been working on a series hybrid plane, with electric ducted fans, small batteries to act as a storage buffer, and a gas turbine generator in the hold, though there is no talk of an after-treatment system to reduce these combustion emissions. Also, this company has had significant setbacks recently, but they say this is not from technical barriers, but instead due to funding issues relating to their initial partnership with Boeing and JetBlue. However, there are two more things you may be thinking about. One, surely this will add a lot of extra weight. And two, planes aren't using synthetic fuels and might not be for another decade or two. Now, I couldn't find an estimate for the actual increase in the plane's mass, but the paper by MIT did incorporate it into estimates of how much extra fuel would have to be burnt by the plane, along with other effects like pressure drops in the engine. For this, it was estimated that only 0.5% extra fuel would be required for a given flight, which in my opinion is a small price to pay for the reduced emissions. As far as fuels are concerned, conventional fuels could still be used and would benefit from the reduced nitrous oxide and particulate emissions. Then, as more sustainable fuels are introduced, the life cycle carbon emissions will reduce. For example, Amazon have already signed a deal to buy 6 million gallons of aviation fuel that use a 20% blend of non-fossil fuels. So what do you think about hybrid electric planes? Are they a better bet than all-electric long-haul planes for reducing the carbon emissions of the aviation industry? The engineers at MIT seem to think so. They do note that there are some serious engineering challenges to overcome, but say it is physically possible. I would love to see this combined with the distributed electric propulsion NASA have been working on.